Welcome to another episode of Teachly. Today, we're going to be going over the four main log laws. These log laws are really important, as if you understand these, you can then use them to solve complex logarithm problems. To have a good grasp of this concept, I highly suggest that you first understand exponential laws, as these laws are needed when trying to understand logarithm laws. Okay, let's go over the first one. The first one being the product law. The product law is stated as follows. Log b, open bracket, x times y, close bracket, is then equal to log bx plus log by. In simple terms, this law allows us to simplify logarithms of products into a sum of logarithms. Let's go over our first example. Log 10, open bracket, 2 times 5, can be expanded as such. Log 10, 2 plus log 10, 5. To solve this problem, we simply have to multiply the two numbers inside the bracket together, which becomes 10. There is a law in logarithms that states that if the base is the same as the number inside the bracket, then the solution is simply 1. So therefore, the answer here is just 1. Let's move on to our second law. Log law 2, quotient law. The quotient law is stated as follows. Log b, open bracket, x divided by y, close bracket, is then equal to log bx minus log by. This law allows us to simplify logarithms of quotients into a difference of logarithms. Here we've got an example. Log 2, open bracket, 16 divided by 2. We can expand this to be as such. Log 2, 16 minus log 2, 2. In our previous example, we stated that if the base is the same as the number inside the bracket, that the solution becomes 1. Given this information, we can now answer this question. Log 2 of 16 becomes 4 minus 1, which then equals 3. There is your solution. Let's move on to law 3. Log law 3 is that of the power law. The power law is stated as such. Log b, open bracket, x to the power of n, close bracket, is then equal to n log b, open bracket, x, close bracket. This law allows us to move a power from inside a logarithm to the front of the logarithm as a coefficient. In our example, we have log 3, open bracket, 27 to the power of 2, close bracket. The first thing that we want to do is we want to move the exponent to the front. Therefore, our answer then becomes log, or rather 2 log base 3, open bracket, 27. The next step is to look at the 27 and to find the prime bases of this. If we do this, we then get 2 log 3, open bracket, 3 to the power of 3. Based off the law that we just learned, we can now take the exponential 3 and move it to the front as well. This means that the 2 gets multiplied by 3. We simply have log 3, open bracket, 3. Given the law or rule that we learned earlier in the other two laws, we can change log 3 bracket 3 into 1. And so the answer becomes 2 times 3 times by 1, or simply 6. Let's go on to our last one. The last law is changing of base law. So if we have log b to the power open bracket, x, close bracket, this then equals log c, open bracket, x, close bracket, divided by log C, open bracket, B, close bracket. So what you see here is that if we divide by the same base, we can then change the base of the logarithm. In simple terms, this law allows us to change the base of a logarithm to a different base. In our example, we have log 5, open bracket, 100, close bracket. We could change this to log 10, which is a natural log, open bracket, 100, close bracket, divided by log base 10, 5, which was our original base. When we do this, we then get log 10 of 100 to be equal to 2. And if you put log 10, open bracket 5, close bracket into your calculator, you will then get 0.69897. If you put the last expression into your calculator, it'll simplify to 2.30103. And there you have used the change of base law to solve your problem. Awesome. Thank you so much for watching this video. I hope that you found it insightful. If you did, please like the like button and subscribe to this channel if you want to hear more content like this. Thank you and have a great day further.